Next chapter, squares and square roots. When a number is multiplied by itself, the product is called its square. So 4 times 4 is equal to 16. We say 16 is the square of 4. In shorthand, the square of a number n is given as n raised to power 2. And so 4 squared is equal to 16. 1.2 squared is equal to 1.44. 0.8 squared is equal to 0.64, and so forth. When working with small whole numbers, finding the square is quite easy, perhaps because over time we have managed to have the multiplication tables at our fingertips. But it gets more complicated when working with decimals, and multiplying the numbers might be tedious and time-consuming. Luckily, we have mathematical tables of squares of numbers from which you can read the square of any number. This is a sample page of the tables of squares of numbers. In this section, we shall learn how to find the squares of whole numbers and decimals using this table. These tables provide the squares of numbers from 1.000 to 9.999. The table has 3 main sections. 1. The column headed by X, featuring numbers from 1.0 to 9.9. This column provides the first decimal place of the number whose square we want to find. That is to say, if we want to find 6.783 squared, the first decimal place, 6.7, is found in this column X here. This column is then followed by 10 columns headed by 0, 1, 2 up to 9. These columns provide the second decimal place of our number. And so for our number 6.783, we shall go to the column headed by 8. And since our first decimal place fell under 6.7, we shall follow this row of 6.7 up to where it coincides with the column headed by 8. We read this number. It's 45.97. But we still have 3 in our number. What about it? The table has the last column headed by 1, 2, 3 up to 9. Below them it's written add. This column tells us what to do with the third decimal place digit, in our case 3. We proceed with our row up to the point where it coincides with the column headed by 3. We read the number. It's 4. So we add 4 to our previous reading. So we shall have 45.97 plus 4, and that gives us 46.01. And so 6.783 squared is equal to 46.01. Notice that 4 is added as 0.04 and not as a whole number. Next example, 8.458 squared. First decimal place is 8.4, so we are here. Next is 5. The column of 5 and the row of 8.4 coincide here. We read this number. It's 71.40. The last columns for adding. The column of 8 coincides with our row here, and the number is 14. We add to 71.40 and we get 71.54. So 8.458 squared is equal to 71.54. From this table, you realize you can only find the square of numbers with a maximum of 3 decimal places. So if there are more, you have to round off the number. Next, 7.32 squared. First decimal place 7.3, so we are here. Next digit is 2. The column of 2 coincides with our row here. The number is 53.58. We do not have a third decimal place, so we stop there. And so the square of 7.32 is 53.58. How about 6.0 squared? This is the same as 6.00 squared. 6.0 is here. Next digit is 0 and we read the number at column 0. That is 36.00. Finally, 5.808 squared. First decimal place, 5.8 is here. Column of 0 will coincide with the row here, so we have 33.64. We then move to the add column and locate 8. They coincide here and we have 9. We add that and we get 33.73. So the square of 5.808 is 33.73. Now we have seen that the tables give square values for numbers between 1.000 and 9.999. What about numbers greater than 9.999? In such cases, we simply express the numbers in standard form. For example, 843.7 squared. We first express it in standard form, so we have 8.437 times 10 raised to power 2. Then everything is squared. Proceed now and read the squares. 8.4 is here. The column of 3 meets us here. The number is 71.06. The add column for 7 meets us here. The number is 12, and so we add to 71.06, and that gives us 71.18. 10 squared is equal to 10 raised to power 4, and so we have 71.18 times 10 raised to power 4. We move the decimal leftwards, so we have 7.118 times 10 raised to power 5. You can leave your answer like that or give it in full, and that will be 711,800. Let us now have 0.00613 squared. In standard form, we shall have 6.13 times 10 raised to power negative 3, and then everything is squared. To the tables now. 6.1 is here. The column of 3 will meet us here. The number is 37.58. We do not have a third decimal place, and so we end there. Square of 10 raised to negative 3 is 10 raised to negative 6, and so we shall have 37.58 times 10 raised to power negative 6. The decimal can move leftwards, so we get 3.758 times 10 raised to power negative 5. Notice that moving the decimal leftwards increases the power of 10 from negative 6 to negative 5. Next, we look at square roots. Again, the square roots of certain numbers are often at our fingertips, like the square root of 81 is 9, square root of 36 is 6, and that of 121 is 11, and so on. Numbers whose square roots are whole numbers are called perfect squares, like 81, 36, 121, 100, and so on. Majority of numbers, however, are non-perfect, but that does not mean they don't have square roots. Decimal numbers too have square roots. Mathematical tables of square roots help us find these square roots. This is a sample of the tables of square roots. It has the same columns as the tables of squares. However, the square root tables give square roots for numbers from 1.00 to 99.99. We read the tables the same way. For example, the square root of 6.598. Here we use the tables of numbers between 1 and 9.99. 6.5 is here. If you look at the column of 0, the figure is 2.5495. But looking at the columns of 1, 2, 3 up to 9, there is no decimal indicated. What that means is that all the numbers in this row start with 2 points, even though it's not written. So we go to the column of 9. They coincide here. The number is 5671, but it has to start with 2 points, so it's actually 2.5671. In the add column, we go to 8. The number here is 16, and so we add it to the first reading. So we have 2.5687. That is the square root of 6.598. Square root of 91.8. Here we go to the tables from 10 to 99.99. 91 is here. The numbers in this row all begin with 9 points. So we go to the column of 8. The number is 5812. So it's actually 9.5812. No second decimal place, and we stop here. So the square root of 91.8 is 9.5812. For numbers less than 1 or more than 100, we write them first in standard form. But in writing in standard form, the power of 10 must be divisible by 2. In other words, it has to be an even number. For instance, the square root of 793. In the standard form, that would be 7.93 times 10 raised to power 2. And then the square root of everything. Read from the table. 7.9 is here. The row starts with 2 points. We go to the column of 3, and the number is 8160. And so we have 2.8160. Square root of 10 raised to power 2 is 10 raised to power 1, or simply 10. So we shall have 2.816 times 10 raised to power 1, or simply 28.16. How about the square root of 5,584? In the proper standard form, that would be 5.584 times 10 raised to power 3. But there's a problem, because 10 raised to power 3 is not a perfect square. We need to make the power an even number. And so we move the decimal to the right and have 55.84 times 10 raised to power 2. Square root of 55.84. 55 is here, coinciding with 8 here. We have 7.4699. Next, the add column coincides with 4 here. We have 27, and so we add it here. So we shall have 7.4726. Square root of 10 raised to power 2 is 10 raised to power 1. And so we shall have 7.4726 times 10 raised to power 1, or simply 74.726. Let's try square root of 0.00829. In standard form, that would be 8.29 times 10 raised to power negative 3. But 10 raised to power negative 3 will give us problems. We make it an even number. We move the decimal to the right one more step. And so we shall have 82.9 times 10 raised to power negative 4. Square root of 82.9 is 9.1049. Square root of 10 raised to negative 4 is 10 raised to negative 2. And so we shall have 9.1049 times 10 raised to power negative 2, or simply 0.091049. The important thing is to make sure that you are reading the right tables so you don't confuse the tables of squares and those of square roots. Good luck.
If you've had a bad experience with math, you tend to sort of slough it off, and that's a serious mistake, I think. I believe with the right resources and help, most people can learn most of the math that they need to learn. But in almost any class that you go into, you need to make sure that you're at the starting point. People come in with different backgrounds, different preparations, and so you're not all on the first day at exactly the same place. And so you can go on and learn math. You may need tutorials, you may need tutors, etc., to get your foundation solid so that you can build the next course on it. But math is not so complicated that most people can't learn high school math and certainly the introductory courses in university. But I think too many people stop out too soon because they've had bad experiences.